Namaste. हमेशा खुश रहो बिटिया. I am Jv'n Dr. Lily Trivedi from Jyoti Vidyapeeth Women's University, and today I am going to take a lecture on tissue test for mineral nutrients. Now this is a lecture for the program B.Sc Honors Agriculture Second Sem, and the course is Fundamentals of Plant Crop Physiology Lab. Now, let us start with the session. Now, what is the tissue test? There is a rapid tissue test which pays a nutritional problem for quick recovery. Now, what happens whenever a plant is facing some deficiency of nutrition through nutrients, micro or macronutrients, this test is a solution for how to find out which nutrient is lacking. So, this rapid nutrition tissue test is a quantitative estimation of both plant and soil for nutrient concentration and for applying the useful and economic fertilizer in a long-term strategy. Now, on dry weight basis, the normal healthy cultivated plant will have a foliar concentration of essential elements. Now, this will depend on the variety, type of soil, growth, and other operations. Now, what happens when the plant is a deficiency? It shows either some symptoms, as we have already discussed. So, it shows some deficiency symptom. But if it is not showing the deficiency symptom, we can individually test the tissue of the plant for the deficiency nutrient. So for example, we have over here, now the cereal crops, we take them for nitrogen deficiency, we take the stem midrim. For phosphorus, the leaf blade is taken. For potassium also, leaf blade is taken. Now in different crops, there is a difference of the tissue which is taken. But usually for nitrogen, the petiole and stem midrib is taken. For phosphorus, potassium, the leaf blade, petiole and leaf lamina is taken. So as if you study this table, we find that usually the leaf or the leaf petiole or the leaf blade is taken for tissue test. So for fruit trees, leaf blade, midrib or leaf lamina can be taken. For ornamentals and tea and coffee, leaf blade should be taken. And for micronutrients testing also, the leaf lamina, leaf blade and midrib portion is taken. Now the different tests. For nitrogen, the procedure is, the reagent is 1% diphenylamine in concentrated sulfuric acid. So small bits of leaf or petiole are taken in a petri dish and a drop of 1% reagent is added. The development of the color indicates the nitrate or the nitrogen, and the degree of the coloration indicates the amount. If there is a dark blue, it is sufficient nitrogen is present. Light blue, slightly deficient nitrogen, and no color shows highly deficient nitrogen. For phosphorus, the reagents are ammonium molybdate solution, stannous chloride powder, 8 gram of ammonium molybdate dissolved in 100 ml of distilled water. To this, 126 ml of concentrated hydrochloric acid and made up to 300 ml of distilled water. And the stock solution is kept in amber color bottle, and when it is used, it is diluted to the ratio of 1:4. Now, the teaspoon of freshly chopped leaves are taken in a test tube and 10 ml of this reagent is added and kept for a few minutes. After shaking, a pinch of stannous chloride is added. Dark blue color indicates sufficient phosphorus and bluish green indicates slightly deficient, but no color means highly deficient phosphorus. Third is potassium. Now for potassium, sodium cobalt nitrate reagent and ethyl alcohol is taken. For sodium cobalt nitrate reagent, we take 5 gram of cobalt nitrate and mix with 30 gram of sodium nitrate in 80 ml of distilled water. To this, we add 5 ml of glacial acetic acid and make it to 100 ml of distilled water. Now the dilute reagent is prepared with 5 ml with 15 ml sodium nitrate to 100 ml using distilled water. The cut leaf bits are taken in a test tube and 10 ml diluted reagent is taken, added and shaken vigorously in this test tube and kept for 5 minutes. After this, we add 5 ml of ethyl alcohol and keep it for 3 minutes. Now the turbidity indicates potassium. No turbidity, high deficiency of potassium, moderate turbidity, moderate deficiency, and high turbidity means sufficient potassium. Calcium, for calcium, Morgan's reagent is taken, that is 30 ml of glacial acetic acid in 100 grams of sodium acetate, which is dissolved in a little bit of distilled water. So 0.5 gram of the cut plant material is taken, and we have the both healthy and deficient plant in different vials, and 5 ml of the Morgan reagent is added. After 15 minutes standing, 2 ml of glycerine and 5 ml of 10% ammonium oxalate is added. Now this solution is shaken for 2 minutes. The turbidity resembling after 15 minutes indicates the amount of calcium on the normal plant tissue. Then we have magnesium, and the reagents are pure sucrose 5%, 2% hydroxyalumine hydrochloride, titan yellow, sodium hydroxide. Now we are dissolving 150 mg of titan yellow in 75 ml of 95% ethyl alcohol and 25 ml distilled water. So a teaspoon of finely cut material is taken and these reagents are added in sequence. 1 ml of sucrose, 1 ml of hydroxyalumine hydrochloride, that is 2%. Sucrose we have taken is 5%, and 1 ml of titan yellow. And finally, the solution is made to alkaline by adding 2 ml of 10% sodium hydroxide. Now, the red color indicates the magnesium and yellow color indicates the absence or traces of magnesium. So, the red color is required and yellow color shows deficiency. Now, for iron, we use finely cut leaf material, that is 0.5 grams in a glass vial and 1 ml of concentrated hydrochloric acid. After 15 minutes, we add 10 ml of distilled water and 2 to 3 drops of concentrated nitric acid. 10 ml of this solution is prepared out in a specimen tube, and after 2 minutes, 5 ml of 20% ammonium thiocyanate is added and stirred. Further 2 ml of amyl alcohol is added. It is shaken well and allowed to stand. Now here also the intensity of red color of amyl alcohol indicates the quantity of iron present in the tissue. So students, thank you very much. I hope you are satisfied with my digital session. I have taken my work from this reference, and if you have any query, please write in the comment box. I will resolve it soon. This digital session was powered by 2.0 version of Jyoti Vidyapeeth Women's University. Thank you. Namaste.